Hello, this is Mrs. Kohler. Welcome to the podcast on transition metals and ionic compounds. On my website, this is listed as podcast 2B because it is the second of 3 parts on ionic compounds. Essential question is the same as it was before. So look at the 2 pictures here of iron oxide, and you can see that they're 2 different colors. The one on the left is reddish, and the one on the right, it has more of a black color. They are both iron oxide, but they have different properties because they came from different forms of iron. So iron has the ability to have different charges, also called oxidation states, making it multivalent. And multivalent sounds complicated, but it's really not that bad. Multi means many, and valent refers to valence electrons, which you did in the last unit. Valence electrons are those outermost ones that are involved in bonding. So multivalent just means it can have different numbers of valence electrons. So ferric, which was used in the first compound you saw, has a charge of +3, whereas ferrous, another form of iron, has a charge of +2. So iron is what's called a transition metal, and transition metals are those elements in the center of the periodic table, the ones that on the last podcast I said don't worry about these. It's these right here, the ones that I just circled. Those are called transition metals, and all transition metals can have more than one charge. So we're going to learn how to tell which charge it is. So, for example, there is ferric oxide and there is ferrous oxide. Ferric oxide uses the version of iron that has a charge of +3, and oxygen, of course, has a charge of -2. So the formula for this is Fe2O3. Ferrous oxide is the version of iron that has a charge of +2, and oxygen is -2, and it makes a formula of FeO. And I'll show you how to do that in a minute. So there's 2 ways to name it. One is using Roman numerals, so iron 2 oxide or iron 3 oxide. The other way to do it is what's called classical. And these are old Latin names. There's ferrous and ferric. So when you're naming things with Roman numerals, the first example that you have here is Fe2O3. So the first thing that you have to figure out is what the charge of the iron is, because iron can have a charge of 2 or 3. So the best way to do that, remember when we were figuring out the formulas, we brought down the exponents. Well, now we're going to bring them up to find the charge of iron. So we get, for oxygen, we get 2, which is accurate. So for iron, which is always positive, we're getting a 3. So it's the version of iron that has a charge of +3. So for Roman numerals, we're going to name it iron, parentheses, Roman numeral 3, oxide. Now the other option we have is FeO. Now for this one, you could try bringing up the numbers, but what you end up with is a 1 for Fe and a 1 for oxygen. And we know that that's not the correct charge for oxygen. We know that the charge for oxygen is -2. So in order for one iron to cancel out a -2, it must mean that that iron has a charge of +2. So +2 plus -2 equals 0. So this must be the iron with a +2. So its name is going to be iron 2 oxide. So that is how you name with Roman numerals. Now remember that Roman numerals are only telling you the charge on the transition metal. It doesn't tell you anything about the other element. Now when you're naming using the classical rules, you have to get out your ion chart, which is that gray card that I gave you. So we're going to do this with the same two compounds as before. So Fe2O3, which we already determined, has the charge of +3. And what you need to do is you need to look on your ion chart for Fe, whose name is ferrum. It says iron next to it. And the +3 has the suffix IC. So you're going to take the word ferrous, but change the N to IC. So it's ferric oxide. Now with the other one, the FeO, we already determined that the iron in that case had a charge of 2+. So you look on your ion chart, and again, it's ferrum, but we're changing the N to OUS. So FeRr, and then the N changes to OUS, oxide. So that's how you name with classical naming. A shortcut is the suffix IC goes with the higher charge and OUS goes with the lower charge. Okay, now here's some other examples. Chemical formula for tin 2 oxide. The symbol for tin, which you can get off of your ion sheet, is SN. And you know from the fact that there's a Roman numeral 2 that its charge is +2. And then oxide is a -2. So bring down your numbers and you get SN2O2, and don't forget to reduce, so you get SNO. Cuprous oxide, now this is a classical name, so you have to look on your ion chart and find cuprum, which is copper, and the OUS means it has a charge of +1. So you're using copper with a charge of +1 and oxide with a charge of -2. Cross over your numbers and you end up with Cu2O. Now in this one it gives you the formula, but you have to name it. So CrCl3. Cr is chromium, so you do chromium, and then something's going to go in these parentheses, chloride. Since Cl had a 3 after it, you can bring this 3 up here and this 1 up here, which means Cr had a charge of 3+, which means the Roman numeral should be 3. And then the classical name for Crs. So Cr, again, is chromium. Now, this isn't on your ion chart, so if it's not there, you would just assume that it's the regular element name and you're changing the ending. So CHROM, the other form was +3. This one is going to be, well, sulfur is 2-, so for there to be one of each, this one has to be 2+. So the 2+ is the smaller number, which means it's going to be OUS, and then sulfide. So that's how you name ionic compounds that have transition metals. Now you're going to want to go and do pages 12 and 13 in your packet. Have a great day.